Мы попробуем по-английски и какие-то непонятные места для русскоговорящих продублируем на русском. So we will speak in English. And what will we do? We will help our Russian participants who may be not that great in English, and we will translate into Russian some tricky parts. Okay, maybe we will wait just a couple of minutes so everybody could get to our conference. And I have a suggestion. Maybe you could turn on your web cameras. So it would be nice for us to see real people and not black squares with names.
And numbers.
And numbers. So I guess we'll start now. Please feel free to make yourself some tea because it's a tea party. So at the beginning, I probably would ask, do you have any questions about our problems? And my colleague Andrei has something to tell you, a couple of ideas. So yeah, you can think about your questions, and I guess Andrei will start his talk right now.
I have a question, but it's more. Can I ask a question? Right
Yeah,
now?
sure.
Or should I wait? So I have more of technical question.
Okay, it's hard to hear you. Maybe there are some problems with your mic. So I heard just the beginning of the question, and now I hear nothing. You can type it in chat. We have chat here in a Zoom conference.
Can you hear me?
Yes, now I can hear you.
Yeah, unfortunately I got kicked out. So on problem 15, can we empty our сосуды or no?
No, the water should be transferred from one jug to another. You can't just spill it on the ground.
Okay, thanks. That's it.
So, Andrei.
Okay, we want to encourage you to solve our problems. So there are some facts related to our topic that we can discuss here. First of them is called Bertrand paradox. It's a famous problem, and let me show you a picture.
Am I the only one who has problems with the sound? Or it's I don't hear Andrei. Yes.
Are you hearing me?
Yes, now we can hear you.
Okay. So I'll talk about Bertrand's paradox, and it's a problem that might about geometrical probability. So the problem is the following: we have a circle and equilateral triangle inscribed in it, and we took a random arc of the circle, and the question is what is the probability that the arc of this arc is greater than the arc inscribed in
So maybe not arc, but line segment. You mean?
Yes. So what is the probability that this line segment is greater than the side of this triangle? And there is several solutions to that problem, which give us different answers. So first solution is the following. Suppose we put first point somewhere, no matter where it appears, and we can plot the set of other points such that resulting line segment will be long enough, and we can see we can inscribe a different triangle into the circle, and the points here will correspond to the cases when our line segment is long enough. So seemingly probability of success is 1/3. But there is another thing which says that first we may note that to describe a line segment, we can only point to its center, because if we have a center, we can draw a original line segment. Yes. Может, у кого-то есть вопросы по-русски, если, ну, кто слушает, кто пытается понимать.
Я пытаюсь понять, но я пока еще не дошел до того, что имеется в виду. На самом деле у меня главный вопрос, я еще так и не понял, ну, задачу я не до конца понял. Можете ее, пожалуйста, по-русски проговорить?
Oh, now I will state the problem in Russian. Проблема такая, что вот у нас есть вписанный треугольник в окружности, и мы берем случайную хорду этой окружности. Вопрос такой, с какой вероятностью эта случайная хорда длиннее, чем сторона треугольника?
Окей, хорду мы просто произвольно на окружности две точки берем, это... хорда, сори, да.
Да, условие такое, берем случайную хорду, случайно, вот, и...
Отлично. Ну, радиус типа 1, да, все дела, да.
Okay. So, in order to take a random line segment, we can take a random point in a circle, and for which points our line segment will be long enough. It's quite easy to see that here our equilateral triangle, and this angle is 60 degrees. So if our point gets here, so this radius is 1. So this distance is 1/2. So if our random point gets over the 1/2 from the center, our line segment will be too short. So in order to get a long line segment, should get to the described circle in the triangle, and the radius of this circle is 1/2, which means that the area of points inside this circle is 1/4, which
So the ratio of the area of the original circle to the ratio
yes.
inscribed is 1/4, yes? Okay.
Yes. So we have two different answers to the same problem, which looks strange. But the reason is that the original problem was not well defined, because there is many ways to generate randomly a line segment on the circle. So our two answers is the correct answers, but for different ways to generate this line segment. When we analyzed the first way, we took two random points on a circle, but in this procedure we took random point inside circle and treat that point as a center of our line segment. And in result, we have, for these different generation procedures, we have that one event has different probabilities. And we may look this picture appears when we put many points randomly in a circle. So we have some random mass of points. But if we would if we take two random points on a circle and take its center, the picture will be very different. It was something like that. So it's two random mass of points, but we see that there is a bit more concentration in the center. So that is a different distribution of points. And you have any questions?
Yeah, I have a question. Once again, what causes it to be like differently scattered? You can actually repeat it in Russian if you want, since yeah.
The reason that points are differently scattered is that we generate it using different procedures.
Yeah, and, I just didn't hear the difference in these procedures. Yeah. So what's different in the first case? What makes it different from the second?
First is when we take 2 points, randomly take 2 points on the circle, and then draw a line. And the second procedure is when we get random point inside a circle, and then say that this point is a base of the perpendicular from the center of the circle to our line segment.
Yeah, then these points which are scattered, what do they represent? So they represent...
Yes, points in this picture represent how scattered centers of the arcs that generated by a first way when we took 2 different points on the circle. And if we take
just random point inside, it's a different way. Yeah.
Да.
Okay.
If we take random points inside, it looks like this. And there is no additional density of points in the center.
Okay, thanks.
So another way of generation leads to that the same area of this picture, or maybe we may say of this phase space of line segments. So the same area here and here have the different probabilities. So we cannot calculate probability of this event simply by calculating pressure of the areas. So there is a common problem with problem 2a, that there is some picture, and there is some figure inside this picture which represents the event which interested. And but sometimes there is a problem that that in fact, if we look at the scattering of the points on that picture, it will not be uniform. So the calculation of pressure of the figures will not yield a proper answer. Я надеюсь, тем, кто слушает, русскоязычным слушателям было что-то понятно. Могу повторить какие-то ключевые моменты.
Да, вроде ясно.
Спасибо.
So this was a small hint for problem number 2a and for the way of thinking about geometrical probability. And so if you have any questions on that topic, please ask. And I know that Andrei wants to talk about one more idea. For problem, for which problem? I guess for problem number 9, yes?
Я там не вылетел.
Okay, we probably have some technical problems.
Ничего не... Короче, пропал.
Так, вот здесь остановить не сделать.
So what's going on?
В данный момент мы обсуждаем, ну, нам показали одну такую подсказку для 2А. И все. Сейчас еще что-то покажут. И мы еще говорим на английском.
Андрей, срочный вопрос. Что со шляпами?
Андрей вышел.
Андрей вылетел, он сейчас вернется.
Настя, срочный вопрос. Что со шляпами?
Hello again.
Hello.
There is a second message that probably in some problems with geometric probabilities, you can explicitly describe a figure and which corresponds to a proper event, and you get stuck to calculate exact area of this figure. You may send out as a solution in that state, because so there are some problems where calculation of areas requires integration, and we don't want that this technical difficulty prevent you to get further. So, and there is one more idea that may help you in problems 9 and 10. There is one famous problem which sounds like that. We have k lines, and the question is how many pieces of plane we can get with this k lines. And there is a standard proof of this fact using induction, and it states that we can get at most k squared plus k over 2 plus 1 pieces. You can use it as a known fact, and it may be helpful in problems 9 and 10.
I have a
There is
question about
actually,
problem number 9. Okay.
yeah, I just want to say that there is a simple proof of this fact by induction. You can try it for yourself.
Yes, so the question about number 9, we're told that they're equivalent if we can move one into another without touching any nail. So what does a movement represent? It's just a vector, or can we turn it, or whatever?
Yeah, we definitely can turn it.
So a movement is what?
So it's a composition of turns and translations.
Okay, thanks.
So now we will be glad to hear some questions. Probably every participant can ask 3 stupid questions and we will answer.
A question. When will we get a new set of problems?
So our semifinal is 29th?
Tomorrow, yes.
29th,
Yes, tomorrow, the day after tomorrow, we will discuss solutions of these problems. And I guess that the new set will be published, what, the day after tomorrow?
Mhm.
So on 30th. Okay.
Okay, because mhm.
So probably any more questions while I'm checking our schedule. So yeah, 30th of January looks like a reasonable date.
And also I have seen that we should send our solutions before 8 o'clock, what is it, 29th? Yes. So first of all, it's 8 o'clock, which time? Moscow?
Yeah, it's 8 p.m. Moscow time. So I guess it's UTC +3. Yeah, that's the semi-final. So it's your deadline to send all you have for part 1.
Okay.
So it will be tomorrow. Okay, any more questions?
I guess no.
So yeah, if you don't have any questions, I guess you're free to go, or you can just chill out in chat here. So basically do whatever you want.
Actually, it's like a question about ways to solve. So the first 4 questions, I had an idea how to solve because it's just like a geometric representation of possible outcomes, and as coordinates I used what was changing. But for example, in problem number 5, I don't even get what can I draw on a plane to get a phase space of this thing, because there is nothing that changes there technically.
Well, it doesn't have to be something drawn on a plane at the first place. So Andrei, what can we say about problem 5 not letting out the solution?
I mean, so not drawn on a plane. So since it's the topic is phase space, shouldn't it be all about like representing in the space or in the 2D plane? What happens?
Well, phase spaces can take many different forms. It can be some plane figure, but it can be a graph or something drawn on a sphere,
Okay, interesting.
whatever. So did I answer your question?
You gave me food for thought. So
Many problems in our list have not only a phase space solution, so you can come up with other solution.
yeah, that is what I was thinking of. For example, in problem 15, I think there might be a solution that does not include the phase, all about the jars and water. The solution that doesn't include phase spaces. So you accept the solutions that do not implement this topic.
Well,
Or yes.
but we encourage you to dig deeper, of course, and to try to find how phase space are connected, for example, to problem 15.
Okay.
I would say that many of the problems in our list are in some sense famous because often the point of view from so finding a phase space of the problem is usually finding a neat, clever perspective of the problem, and after which all becomes evident, and so it's very cool and sometimes there are many solutions to our problems, but we think the solutions through phase space is most elegant of them.
Okay, thanks.
Okay, so if you have any more questions, please ask. Me and Andrei will chill here for, I guess, 5 to 10 minutes.
Okay, thanks a lot. Have a great day. Actually, about one more question about the semifinal. So it will be held like the opening, where 50 people or so will be in the conference, or it will be held only for each project. It will be held for each participant.
So I mean, discussion of problems after the semifinal, right?
Yeah, after the 30th.
Okay. Actually, we don't know.
Okay, understand. That's nice.
But there will be
Thanks.
an information sent to you, of course, via email and Mattermost.
Yeah, sure. Thanks. Bye.
So it was nice to see some real people. And thank you all for your questions.
That's it for now. Thank you all for the participation.
Thank you. See you. Bye.
Bye.
Bye-bye.
Bye.
Goodbye.
Goodbye.